Hello everyone, so let's start this problem, and it says a bicycle travels 8.10 kilometer due east in 0.490 hours, then 6.70 kilometers at 15° east of north in 0.700 hours, and finally another 8.10 kilometer due east in 0.490 hours to reach its destination. The time lost in turning is negligible. Assume that east is in the positive x direction and north is in the positive y direction. So what is the magnitude of the average velocity for the entire trip? So now for such kind of problems, the best way is to do it on a coordinate frame. And let's see, we need to find the average velocity for the entire trip. So the average velocity, the V average will be, in this case, V average equals to delta of r, the rate of change of displacement. This will be this. Now our coordinate frame, let's make this. So here we have the east direction, the north we have here, then the west and the south. So first it says that it travels to 8.10 kilometer. So it starts from here, it goes, suppose 8.10 kilometer to this direction, and next it goes 6.70 kilometer at 15° east. So suppose after this we have this, and the second is displacement is this 6.70 kilometer at an angle of 15°, and then after that it further goes 8.10 kilometer due east. So it again goes to this direction in 8.10 kilometer. So now to find this total displacement delta r, we need to find the total displacement of all the three motions, this 1, 2 and 3, in terms of delta x and delta y. So let's we calculate the delta x in our whole problem and the delta y. So if we go and make a table like this, so first is this motion when it went 8.10 kilometer to north east. So delta x in this case is 8.10 kilometer, and there is no y component, so this is going to be 0 kilometer. The second is 6.10 kilometer with the 15° angle. So now if you see this right angle triangle, we have two components for this vector. One x component is along this perpendicular, and this is gonna give us 6.70 sine of 15°, and this base of this perpendicular, this will be 6.70 cos of 15°. So the x component for this second vector is going to be 6.70 sine of 15°. When we'll calculate this, it will be 1.73 kilometer. And the y component for this vector is 6.70 cos of 15°. When you'll calculate this, this will be 6.47 kilometers. And the third part of this is again the motion only along the x-axis. So this is again 8.10 kilometer, and the y component is just 0. So now we can find our total x component and the total y component. Just add these three and add these three. So by adding these three, we will get 17.93 kilometer here, and 6.47 kilometer here. So this is the total delta x and this is the total delta y. So once we have these components, we can find our total displacement, that is going to be under root of delta x square of that plus delta y and square of that. So with this formula of delta r vector equals to under root of delta x square plus delta y square, just plug in the values. Delta x is our 17.93, square of this, plus delta y was 6.47 and square of this. So delta r vector, when you will calculate this whole thing, this will come out to be 19.07 kilometers. So we calculate the total displacement in this case. Now we need the total time. So for the time, we are just going to add up the time for all the three different vectors. So this was like 0.490 plus this was in hours, plus 0.700 hours plus 0.490 hours. So the total delta t we have 1.68 hours, and so now our v average is going to be delta r over delta t. This will become 19.07 kilometer divided by 1.68 hour. This is going to be 11.3 kilometer per hour. So that is going to be our answer, 11.3 kilometer per hour, the V average for this problem.